Hello everybody and welcome to this channel. In this video tutorial, we will look at assigning configuration to the chiral center of chiral molecules. Now, a molecule is chiral when it has a chiral carbon or a chiral center in it. A chiral center, or specifically a chiral carbon, is a carbon atom that is bonded to 4 different atoms or groups of atoms. Say for instance, in this compound CH3, Br, H, Cl. This compound overall is a chiral compound because it has a carbon in it that is a chiral carbon. A chiral carbon is a carbon that is bonded to 4 different atoms or groups of atoms. When you look at this carbon, you see that it's bonded to bromine, chlorine, hydrogen, and carbon, and all of these atoms are different. Now, there's a way of assigning configuration to these chiral centers or chiral carbon. And that is by the way of Cahn Ingold Prelog. So the first step here is that you have to rank all those atoms that are directly attached to the chiral center according to their atomic number. So if you want to do that, we are going to start from bromine because bromine definitely has the highest atomic number here amongst all the atoms. So that's going to have priority 1, followed by chlorine, followed by carbon, and followed by hydrogen. Now, a chiral carbon can have just two different configurations. The first one is R and the second one is S. You might be asked, R means rectus, and S means sinister. Okay, so when you draw the arrow from the highest priority to the second to the fourth, to the second to the third, from the first to the last, basically. Okay, and that arrow points, in this direction, which is the clockwise direction, then that configuration will be R. But when it points in an anti-clockwise direction, okay, that configuration will be S. So when you look at this, and when you are drawing that arrow, it doesn't matter whether it passes through the fourth or not. When you are drawing the arrow, just that it must follow from 1, 2, and 3. If it passes through the fourth one along the way, it doesn't matter. So when you draw the arrow from first, second, up to the third, you'll see that it is a clockwise, stuff. So in that case, this configuration will be R. Okay, and if you want to name this compound overall, it's going to be R. Okay, in this bracket dash, you now name this compound. This compound, when you want to name it, is an hydrocarbon. It's not really an hydrocarbon, but it's an alkane. Let me put it like that. It's an alkane that is substituted by bromine, where 2 hydrogen are substituted by Br and Cl. So this is supposed to be H3C, CH, then we are supposed to have 2H as well. So, and that's going to be ethane. But because these 2H are substituted with chlorine and bromine, you must show that in your name that the 2 hydrogen are substituted. So, and if you want to name it, normally you are going to start from this carbon because that's going to give the lowest numbering to your substituent. So, and you're going to name them as well according to their, in alphabetical order. So, in the first carbon, we have bromine. So, that's going to be 1 bromo. Then you know that at the first carbon, hydrogen is substituted with bromine. And we also have 1 chloro. Okay. Again, that another hydrogen at the first carbon is substituted by chlorine. Then the parent name is going to be ethane, like that. So, that will be 1 bromo, 1 dash bromo, 1 chloro, ethane, because we're having 2 carbon alkane. So you separate number and letter with dash. So that is how to assign configuration for the chiral centers. Now let's look at another example. Let's say we have this compound. Now, when you are using the stick formula, we are going to be having hydrogen here. Okay, normally we should be having 3 hydrogen here, but those hydrogen are implied hydrogen. We don't normally put it. This one too is having 2 hydrogen, and this one too is having 2 hydrogen. So anytime you're having your substituent on the wedge, okay, definitely the hydrogen there will be on the ash. That's just the meaning. So when you look at this carbon, it is not a carrier carbon because it is bonded to just a carbon and 3 hydrogen. So it is not bonded to 4 different things. So we cannot consider this carbon as a carrier carbon. Now when you check this carbon, it is bonded to bromine, hydrogen, a carbon, and these groups of atoms. So it is bonded to 4 different things. So this carbon is actually a carrier carbon. So this carbon is a carrier carbon. Okay, but when you check this, it is not a carrier carbon because it is bonded to 2 hydrogen, a carbon, another carbon, then 2 hydrogen. Okay, so we cannot consider this as a carrier carbon. Definitely, this one will not be a carrier carbon because it's bonded to even 3 the same atoms. So the only carrier carbon that we have here is just this one over here. Now to assign configuration for that, you follow the same step. You first have to put you have to assign configuration. You have to assign priorities to all these 4 different stuffs that are bonded to this carbon. So the first one will be bromine because having definitely the highest atomic number. So that would be 1. So let me be using different. So that would be 1. Now the second one, normally this one will have the 4th one because it is the lowest atomic number of all. So because we're having carbon here, we're having another carbon here. Now which one are we going to choose at the second and the third? So when you look at it, the 2 of them that are directly attached to this carbon, they are also carbon. Now, in fact, if you want to break the tie, you're not going to look at what is directly attached to those carbons too. When you look at this carbon, it is attached to 3 hydrogens. And this one here is attached to 2 hydrogen and 1 carbon. So this one is attached to 3 hydrogen and this one is attached to 2 hydrogen and 1 carbon. So we are going to break the tie with this 1 carbon because we have seen, in fact, if 2 hydrogen cancels 2 hydrogen here, we have just 1 hydrogen and we have 1 carbon. So carbon is bigger than hydrogen. So this one will take the priority like that. So if this is 1, okay, if this is 1, this will be 2, this carbon will be 3, and this will be 4. So when you now find your configuration, that will be from 1 to 2 to 3. So this is a clockwise, right? It's a clockwise configuration, and that's going to be R. Okay, so this is going to be R in brackets. You push dash, then you name this compound. First carbon, second carbon, third carbon, fourth carbon. That is butane. And we're having a bromine substituent at the second carbon. So that's going to be 2-bromo. Okay, 2-bromo butane. 2-bromo butane. So that's going to be our name. Now, sometimes, generally, if you want to name those compounds, anytime you want to name those compounds, you want to find the configuration, your hydrogen must be on the ash bond, or the lowest priority group must be on the ash bond. Okay, but in some situation whereby it is not there, for instance, this next example, let's consider that, like this one. How are we going to do? Say for instance, we're having this, and your chlorine is here, for instance, and we're having something like this, we're having maybe double bond OH. And you're asked to find the configuration of this compound. So this first carbon is actually not a carrier carbon because it is bonded to 3 hydrogens. So it's not a carrier carbon. This one is actually a carrier carbon because it is bonded to carbon, that's first, chlorine, and hydrogen. Now, if your substituent is at the ash, then the implied hydrogen that should be here, because normally there should be hydrogen here, but we don't normally put it, that one will be on the wedge. If the first one is on the ash, then your hydrogen will be on the wedge. If you have something like this, where your substituent is on the wedge, okay, then your hydrogen will be on the ash. So since we are having our substituent on the wedge, on the ash, then our hydrogen will be on the wedge. So in this case, if you want to assign the priorities, normally this will be 1, okay, then followed by which carbon, because this will be 4. Hydrogen is having the least atomic number, so it will be 4. So, but which one will have the highest priority, higher priority between this carbon and this carbon? This one will have higher priority because it is bonding to a particular carbon and 2 hydrogen, and this one is bonding to 3 hydrogen. So 2 hydrogen cancel 2 hydrogen, 1 hydrogen left, 1 carbon left. So this one will take the priority and this one will take the next one. So the best thing to do now is that when you're having your lowest priority, in this case hydrogen, if you're having it on the wedge, you are supposed to, you find your configuration normally, and your configuration normally should be, in this direction, and that should be R. But because your hydrogen, which is the least priority, is not on the wedge, it's not on the ash, you have to switch your configuration. So now that we are getting R, your answer will now going to be what? S. So your answer will be S dash. You are now going to name this compound. So that will be 1, 2, 3, 4, 5, 6. But you are not going to name in this direction, because if you want to name, you are supposed to name starting from the carbon next to the functional group. So this is the functional group. You are going to name from here 1, 2, 3, 4, 5, 6. So this is going to be hexanoic acid. And at the position 5, we are having our chlorine. So that's going to be 5 chloro. Okay, hexanoic acid. So that's one of the conditions you need to note. When your lowest priority group is not on the ash, you have to invert your priority. You have to normally find the priority first, then the answer you get, you have to invert it. If you get R, it's going to be S, and if you get S, it's going to be R. So that's it. Now let's look at another case. Another case whereby we're having a double bond. Say for instance, you have this compound. You're having a compound, this, okay, and we're having something like this. Say for instance, we're having something like this. What's going to be our priority? What's going to be our configuration for this chiral center here? Because this is the only chiral center that we have. This one is not a chiral center. This second carbon is a chiral center, and this one is not a chiral center. For it to be a chiral center, it must be bonded to 4 different stuffs. Now, what's going to be our priority here? So this one will definitely have the highest priority. Okay, that will be 1. Now when you look at these 2 carbons now, this one is bonded to 3 hydrogen. 3 hydrogen. This one is bonded to just 1 hydrogen and doubly bonded to oxygen. So in this case, you are going to think of it as if, something like this, right? So you are going to think of it bromine, and we have our hydrogen, don't forget, that will be on the wedge. So you're going to think of it as if it is bonding to 2 oxygen with single bond. This carbon that is A, this is how you are going to visualize it. This is the hydrogen. You're going to think of it as if it is bonding to 2 oxygen atom, because having what? It's having double bond. If it is having triple bond, that would be something like this, even though this is not possible. But if it is having triple bond, it would be as if you treat it as if it is bonding to 3 different oxygen with single bond. So that's how to do that. So in this case, we see that this carbon will take priority, preferentially to this one. Normally your hydrogen will be here on the wedge. We have hydrogen. So this will definitely be the 4th one. So this will be the first one. So this carbon will take priority second, and this one will take the last one. Sorry, the 3rd one. So this is the 1st, 2nd, 3rd, and this will be the 4th. So you still number it normally. You have R in that case. This will be R. But because your lowest priority group is on the wedge, you have to invert your priority. So that's going to be S. Okay. And we have, so you name this normally. So when you want to name this, okay, for you to have something like this, it means there is hydrogen here. So that's an alkanal. So this is bromine, sorry. So this is the 1st carbon, 2nd, 3rd. So that's going to be propanal, and we have bromine at the second carbon. So that's going to be 2-bromopropanol. So that's how to name it. So the point here is that anytime you're having a doubly bonded carbon to another thing, it's like it is singly bonded to that thing twice. So that's what we need to note. So, and another thing here is that, let's look at some other examples. Let's see, maybe we can look at some examples. So if you want to name this compound over here, let me try and copy it. So this compound here, so this compound here, if you want to name this, okay, this one. So if you want to name it, this compound, you just have to start from here. So this is the carrier carbon, okay, and this will have your hydrogen on the ash. So, and this is going to be 1, okay. This will go, we'll take the second one, third, and the fourth. So that will come from here to here. That will be R. So that will be R. Okay, 1, 2, 3, 4. So that will be 2-chloro. You not put dash, sorry. That will be butane. So that's how to name that. So let's say we have this one too. Let's try and name this. If you want to name this one over here, this one that is here. So let's try and name this compound. So this one, this will be the priority. This will be the chiral center, like that. So the least one is here, which is going to be 4. The highest one will be bromine 1. This will be second, oxygen, and the carbon will be the the third, like that. First, second, third. So in that case, your priority will be from here to here, like that, and that's going to be R. So this is going to be R. Now when you look at this, the chirality center is actually this. Okay, this is the chirality center. Now when you look at this chirality center, if you want to assign it, you are going to say first for bromine. Then if you look at these 2 carbon, this is bonded to, this is a carbon that's directly bonded to it, and this is another carbon that is directly bonded to it. If you check what is directly bonded to those carbon too, because this one will be 4th, actually. This will be the first, 4th. Now these 2 carbons, okay, that are bonded to this chiral carbon, which one will take the priority? This one is bonded to nitrogen, oxygen, fluorine, but this one is bonded to sulfur and 2 hydrogen, one here, the other one here. So if you calculate the total atomic number, and out of this, definitely this is bigger than this, but that is not the yardstick. Since we are having just one atom bonded to this one that is having the highest atomic number, this will take the priority, like that. So if this is 1, this is 4, this will be the second one, and this will be the third one. So you have from here to here. So that's going to be your R. And for this, I think I've explained that the other time. So this is going to be, a carbon doubly bonded to oxygen. So it's like singly bonded to 2 oxygen, like that. Now let's look at this example. So this is the chiral carbon. It means that the hydrogen will be on the ash. And this is going to be number 1, nitrogen. Then followed by, this is going to be second, and this is going to be third, and this is going to be fourth. So that will be from here to here, like that. I told you, it doesn't matter if you are passing through 4, but just your aim is from 1, 2, 3. So in this case, it is S, because this is anti-clockwise. So this is going to be S. So if you want to do for this, your hydrogen 2 will be on the ash. So this is going to be 1. Now, which one will be 2? Definitely this will be 4. Which one will now be 2 and 3 between the 2 of them? If you look at this carbon and this carbon, this is attached to 2 hydrogen and 1 carbon. 2 hydrogen and 1 carbon. But this one is attached to 2, it is attached to this carbon and this carbon. Now it is doubly attached to this carbon. So which shows that it is like it is attached to 2 carbon here and another carbon here, so which is 3 carbon. So definitely this one will take priority and this one will become 3. So that will be from 1, 2, 2, 3, like this. Okay, so this one will be anti-clockwise S. Don't forget, this one should be R. I made a mistake. This is clockwise. Okay, this is clockwise. Yeah, that should be clockwise. So for this is hydrogen. And this one is going to be 1, 4. Now, for this one, which one will take priority? Definitely this one will take priority because it is what? It is bonded to 2 another carbon. And this one is just bonded to 3 hydrogen. So this one will take priority. So that will be 1, 2, 3. So this one is just S. And for this is the carrier carbon. Okay, so hydrogen. Carrier carbon is very easy to know. A carbon that is even doubly bonded to something can never be the carrier carbon. So this is the carrier carbon. So this one we have 1 because oxygen is directly attached to it. Now when you check, these 2 carbons, they seem to be the same. Because they are not even the same because this one is attached to carbon and 2 hydrogen. This one too is attached to carbon and 2 hydrogen. 2 hydrogen, 2 hydrogen, 1 carbon. But this carbon too, you still have to break. You know, it's like this. You are having something like this, OH. Then this carbon is bonded to 2 hydrogen and also bonded to CH3. This carbon is the one here and this one is the one here. Now this one is bonded to another carbon. Okay, this is CH2. Actually, this one is there. Now it's not bonded to another carbon that is bonded to oxygen, doubly bonded, and bonded to CH3. Okay, so this one, this carbon here, this one will be 1, and this one we have said, this one is like the wedge, and this one is the hash. So we have said this is 4. Okay, this is 1. So this one and this one now, they are bonded to 2 hydrogen each and 1 carbon. But when you still look at this carbon, it is bonded to 3 hydrogen. And when you look at the carbon that this one is bonded to, it is bonded to 1 carbon and 2 oxygen. So definitely this one will take priority. So this one will now be 2 and this one will now be 3. So you now start from here like that. So that's how you break the tie. You keep checking. If you see that they are having the same thing here, when you check them, 2 hydrogen, 1 carbon, you still consider that carbon they are bonded to check for Now when you look at this structure now, okay, when you look at this structure here, which one will be the carrier carbon? This one can never be the carrier carbon. It is having 2 hydrogen, 2 hydrogen, 2 hydrogen. But this one is the carrier carbon, bonded to oxygen, another carbon, oxygen. But the oxygen is not that they are actually the same. What this is bonded to, this part is actually different from this part. So you can't say that it is bonded to the same thing. So they are actually 2 different things. So if you want to assign the priority now, how will you assign the priority? If you want to assign the priority for this, let me get rid of some things here. So let's look at that. So if you want to assign priority, this carbon is bonded to 4 different things. Now the hydrogen will not be on the wedge because we have our stuff on the hash already. And the hydrogen is going to be 4. Okay, the last one. So which oxygen? Because normally this one will be 3 like that. Because these 2 oxygen, one of them must be one, the other one must be sp2. So it depends on what is attached to them. So when you look at this oxygen now and this oxygen, they are the 2 things that are attached to this carbon. This first one and the second one. So if you look at this, which one will take the priority? Now these 2 oxygen, they are attached to carbon. This first one is attached to carbon and this one too is attached to carbon. But this carbon is attached to 3 hydrogen. 3 hydrogen. And this carbon here is attached to what? 2 hydrogen and 1 carbon. So this one will take priority. So this will be the part of priority 1 and this will be the part of priority 2. So when you look at that, it's going to be from 1, 2, 3 to 4. And that is going to be R. But because your lowest priority group, which is hydrogen, is on the wedge, you are going to change it to S. And this is going to be what? S. And you are going to name that compound. So that's all on how to name and or on how to assign priority. So thanks for watching. I do really appreciate you. Please make sure you like this video and subscribe to this channel for more tutorial. And I wish you the best in your upcoming examination. Thanks for watching.